In this video, I want to look at some application problems that involve systems of linear equations. And let's especially focus on how to set up these equations so that we can then solve them by substitution or addition. Remember, whenever you're solving an application problem, read the problem carefully. Try to identify the main question being asked, and then carefully define your variables to reflect that question. This problem is about a movie theater selling tickets. There are adult tickets and child tickets. And the question being asked at the end is how many children were at the theater? So one of the variables has to represent the answer to that question. It makes sense here to use the variables A and C. A for adults, C for children. Let's see if we can read through the question and set up two equations that involve those variables. One might be more straightforward, and it involves cost. The cost for an adult ticket was $15. The cost of a child ticket was $9. The revenue from ticket sales for the night was $33.90. So all of those relate to cost or money amounts, and we can relate them in a single equation. 15a plus 9c equals 33.90. All right, the cost for adults plus the cost for children times the number of children equals 33.90. But we need two equations in order to solve because we have two variables, right? So the second equation is a little more subtle here. It's more hidden, and that relates to the number of people there are total, or the number of tickets sold. 250 tickets were sold. So the number of adult tickets plus the number of child tickets has to sum to 250. So here is the system of equations that I need to solve to answer this question. Specifically, I need to solve for C. I will choose to solve this system of equations by addition. And so remember, the first step for solving equations by addition is to multiply one or both equations so that the coefficients of one variable are opposites. I will choose to do that with the variable c. So this is 9c. If I can multiply this by -9, then those coefficients will be opposites. So let's rewrite what we have after multiplying the second equation by -9. First equation stays the same. The second equation is now -9a minus 9c equals -9 times 250 is -2250. There's no shame in using a calculator here to help you with some of the calculations. Second step is to add those equations together. So 15a plus -9a is 6a. 9c plus -9c is 0. 3390 plus -2250 is 1140. So I get 6a equals 1140. I need to divide by 6 to solve for a, and a equals 190. Now that actually wasn't what the question was asking for. We were being asked for the number of children at the theater, not the number of adults at the theater. So we're not done, that's not our answer, but that will help us find the number of children. I need to take this value for a, go back up to one of these equations and plug it into one of the equations. I will use the simplest equation that we saw up here, a plus c equals 250. So we know that a is 190, now we're trying to solve for c. 190 plus c equals 250. Let's subtract 190 from both sides, and we get c equals 60. If there are 190 adults, there must have been 60 children at the theater that night. I would recommend checking your answer by plugging it back into the cost equation. 15 times 190 plus 9 times 60 should equal 3,390. That would serve as a check on your work. Always check your answer and make sure it's reasonable for an application problem.